Welcome! Today we're going to learn how to solve equations where the variable appears on both sides of the equal sign. This is an important skill that builds upon your basic algebra knowledge. First, let's see the difference between simple equations you already know and the new type we'll be solving. On the left, we have a simple equation where the variable x appears only once. On the right, we have an equation where x appears on both sides of the equal sign. Notice how in the equation on the right, we have 3x on the left side and x on the right side. This is what makes it more challenging to solve. Our main goal when solving any equation is to isolate the variable on one side of the equal sign. This means getting the variable by itself. We start with our equation where x appears on both sides, and through a series of steps, we end up with x equals a specific number. The key principle in solving equations is maintaining balance. Whatever we do to one side of the equation, we must do to the other side to keep it balanced. Think of an equation like a balanced scale. Both sides must have equal weight. When we change something on one side, we must make the same change on the other side to keep it balanced. We'll use inverse operations to strategically move terms around the equation. Addition and subtraction are inverses, as are multiplication and division. These inverse operations will help us move terms from one side of the equation to the other, getting us closer to isolating our variable. Now that we understand what we're trying to accomplish and the tools we'll use, we're ready to dive into the step-by-step process for solving these equations. Before we solve equations with variables on both sides, we need to review two essential concepts that form the foundation of algebraic problem solving. First, let's review inverse operations. Inverse operations are mathematical operations that undo each other, like addition and subtraction, or multiplication and division. For example, if we have x plus 5, we can undo the addition by subtracting 5. Addition and subtraction are inverse operations. Similarly, if we have 3x, we can undo the multiplication by dividing by 3. Multiplication and division are also inverse operations. Now let's review the second key concept, combining like terms. Like terms are terms that have the same variable raised to the same power. We can combine like terms by adding or subtracting their coefficients. For example, 3x and 5x are like terms because they both have the variable x to the first power. We combine them by adding the coefficients. 3 plus 5 equals 8, so 3x plus 5x equals 8x. Here's another example. 7y minus 2y plus 4. The like terms are 7y and negative 2y. We combine them. 7 minus 2 equals 5, so we get 5y plus 4. Notice that the constant 4 stays the same because it's not a like term with the y terms. These two concepts, inverse operations and combining like terms, work together as the foundation for solving equations with variables on both sides. We'll use inverse operations to move terms around the equation and combine like terms to simplify our work. The first step in solving equations with variables on both sides is to simplify each side of the equation independently. This means we need to eliminate parentheses and combine like terms before we can move variables around. Let's work with this example equation. 2 times the quantity x plus 3 plus x equals 5x minus 1. Notice we have parentheses on the left side and like terms that can be combined. First, we apply the distributive property to eliminate the parentheses. We multiply 2 by each term inside the parentheses. 2 times x equals 2x, and 2 times 3 equals 6. After applying the distributive property, our equation becomes 2x plus 6 plus x equals 5x minus 1. Now we can see all terms clearly without parentheses. Next, we combine like terms on the left side. We have 2x plus x, which combines to give us 3x. The constant 6 stays as it is, since there are no other constants to combine with on the left side. After combining like terms, our simplified equation is 3x plus 6 equals 5x minus 1. Notice that the right side was already simplified, so it remains unchanged. Step 1 is now complete. We applied the distributive property to eliminate parentheses, then combined like terms on each side. Our equation is now simplified and ready for the next step, moving variables to one side. Now we move to step 2, moving variables to one side. Our goal is to gather all the variable terms on one side of the equation using addition or subtraction. Let's work with our example equation 3x plus 6 equals 5x minus 1. We can see we have variable terms on both sides. The 3x term is on the left side, and the 5x term is on the right side. We need to move one of these terms to gather all variables together. We can choose to move either variable term. In this case, let's move the 3x term from the left side. To eliminate 3x from the left, we subtract 3x from both sides of the equation. Remember, whatever we do to one side of the equation, we must do to the other side to maintain balance. So we subtract 3x from the left side and subtract 3x from the right side. After subtracting 3x from both sides, the 3x on the left side cancels out, leaving us with just 6. On the right side, 5x minus 3x gives us 2x. So our equation becomes 6 equals 2x minus 1. Perfect. We have successfully moved all variable terms to one side. Now all our variable terms are on the right side of the equation, and we have only constants on the left side. This sets us up perfectly for the next step. Remember, the key principle when moving variable terms, always use the inverse operation and apply it to both sides of the equation. This maintains the balance and equality of our equation. Now that we have moved all variable terms to one side, our next step is to move all constant terms to the other side. This will help us isolate the variable term completely. We start with our equation. 6 equals 2x minus 1. Notice that we have a constant term, -1, on the right side with our variable term. To isolate the variable term 2x, we need to move this constant term -1 away from it. We do this by using the opposite operation. Since we have -1 on the right side, we add +1 to both sides. Remember, whatever you do to one side, you must do to the other side to maintain the balance. On the left side, 6 plus 1 equals 7. On the right side, -1 plus 1 equals 0, which cancels out completely. Our equation now becomes 7 equals 2x. Notice that we have successfully moved the constant term away, and now we have only the variable term 2x on the right side. Perfect. We have successfully moved the constant terms to one side. The equation remains balanced as shown by our balance scale. We now have 7 on the left and 2x on the right, with no constants mixed with our variable term. This step is crucial because it separates our constants from our variable term, making it much easier to solve for x in the next step. The equation is now in the perfect form to isolate the variable completely. The final and most crucial step in solving equations is checking your solution. This step verifies that your answer is correct and helps catch any calculation errors you might have made. Let's check our solution from the previous example. We found that x equals 3.5 for the equation 3x plus 6 equals 5x minus 1. To check our solution, we substitute x equals 3.5 back into the original equation and calculate both sides separately. First, let's calculate the left side. We substitute 3.5 for x in the expression 3x plus 6. 3 times 3.5 equals 10.5, and 10.5 plus 6 equals 16.5. Now let's calculate the right side. We substitute 3.5 for x in the expression 5x minus 1. 5 times 3.5 equals 17.5, and 17.5 minus 1 equals 16.5. Perfect! Both sides equal 16.5, which confirms that our solution, x equals 3.5, is correct. Remember, if the two sides had not been equal, it would mean there was an error in our solution process, and we would need to go back and check our work. Always make checking your solution a habit in algebra. Now that we've learned the steps to solve equations with variables on both sides, it's important to be aware of common mistakes and learn tips that will help you succeed. The first common mistake is incorrectly applying the distributive property.
When you see 3 times the quantity x plus 2, you must multiply 3 by both x and 2. The correct way is to multiply 3 by both x and 2, giving us 3x plus 6 equals 2x plus 5. The second common mistake is making sign errors when moving terms across the equal sign. Students often forget to change the sign when moving terms. Remember, when you move 2x to the left side, you subtract it. When you move -3 to the right side, it becomes +3. Here are 3 essential tips for success when solving equations with variables on both sides. First, double-check each step as you go. Don't wait until the end to verify your work. Catch mistakes early. Second, take your time. Focus on accuracy rather than speed. It's better to solve one problem correctly than 3 problems incorrectly. Third, practice regularly to build confidence. The more you practice, the more automatic these steps become. Remember, solving equations with variables on both sides becomes easier with practice. Stay patient, work systematically, and don't be afraid to double-check your work.